Hello students, welcome back to Best Academy. Today I'm going to discuss new topic of linear algebra. The topic name is basis and dimension. For starting lecture, first we check what is the basic definitions of basis and dimension. Let's start today's lectures and try to understand what is the basis and dimension. So, check the definition. A basis beta of a vector space V. Number one condition is linearly independent subset of V. This is the one condition. And second condition is that it generates vector V. That will choose here the vector V, vector space V. And first condition is beta must be linearly independent. When it is linearly independent, it means that you're talking about that linearly independent subset of V, then it generates the vector space V. Right, now we choose some queries, some type of examples and try to understand. For example, I'm going to choose an example. What is the normal example? For example, you're going to talk about some simple phi. For example, I have a set like this way, and this is the basically you can say that empty set, empty space, you can say that. In other words, we can say that empty space. When it is empty space, it means that in mathematical terms, it is basis of zeros vectors. Basically, it is zeros vector type things, right? So, if I'm going to talk about, for example, I have an example like 2. Example 2, for example, I have the standard basis of R2. So, if you, for example, talking about the basis dimension 0, 1, and it is the basis of R2. Similar case, when you are talking about the basis of R3. So, you can choose here 1, 0, 0. Here is 0, 1, 0. Here is 0, 0, 1, and it is the dimension of R3 basis. If, for example, I'm talking about in polynomial type, then in the case of polynomial, what will be the basis? For example, I'm took the polynomial of P to R type. When you're talking about the polynomial of P to R type, then you can say that the basis set of polynomial is 1 x squared. Like this way. For example, I'm talking about nth type of polynomial. For example, I'm talking about nth polynomial R. At that case, the basis set is 1 x squared to onward xn. Right. So this is the criteria you can set that. Here you notice that phi is the basis set of zeros vector. R2 has the standard basis 0, 1, 0, 0, 1. R3 has 1, 0, 0, 0, 1, 0, 0, 0, 1. For example, we're talking about polynomial P to R, 1 x squared. For example, you're talking about a polynomial of 1 x to xn. So this is the way you can try. Now we choose examples and try to understand it, how you can sort it with the help of an example. Now we choose the example and try to understand whether this set is the basis set of R3 or not. We already know the definitions, linearly independent, and second thing is that must be understand the condition is generate the space R3. So we choose this set. So we choose first is, for example, like this way. For example, V1 is equal to this vector 2 minus 3 5. V2 vector is this vector 1 0 minus 2. Or V3 vector is this 0 2 minus 1 vector. So by definition of linear combination, that is a1 v1 a2 v2 plus a3 v3 is equal to 0 0 0. The reason is that here is R3 space, so must be the zeros type 0 0 0 0. Now we put the vector in this equations. This is the first vector, that is 2 minus 3 5 plus a2 is equal to this vector 1 0 minus 2 plus a3 vector is 0 2 minus 1, here is 0 0 0, right? So now we're going to multiply and check the values. So I'm going to multiply this equation coordinate by 2a1. Here is the term, if you're going to say that here is the value of 1, that is the vector of this 2. So you notice that there is no values of other vector. If going to 2a1, here is plus 2 plus a2 is equal to 0. Now going to multiply the second term, that is equal to minus 3a1. Here is the term plus 2a3, that is equal to 0. I'm going to coordinate wise is 0 term. So second term is 5a1 term. Here is minus 2a2. Here if you notice that minus a3 is equal to 0. So we have some system of equations, and we know that this type of system of equation we can sort out by using augmented matrix, right? So we can't solve it by simultaneous. The reason is that if you have some variables factors, I'm going to write in augmented form of matrix, so we can written as 2, here is 1, here is 0, and here is the left side of expression constant term will be like this way. So here is this way will be minus 3, right? So here will be here is minus 1, here is 0, and here is 2 term, right? So in second term like 5, and if you're going to say that the second term is minus 2, here is minus 1, right? So so this is the important thing. Now we choose augmented, this is the augmented form. So we solve it, here we need pivot 1. So how you can solve it by pivot 1? So we choose is R1 by R2. So we get the factor, I'm going to multiply by R1 plus adding R2. So here will we generate 1, that is negative 1. So we receive negative 1, here will be a 1, and here will be 2 factor, right? So now here will be 0 type. So here is minus 3, here is 0, here is 2, here is 0. So your last factor will be 5, here will be minus 2, minus 1, right? So now we're going to multiply this term by negative by minus R1, so here will be positive, here will be negative. So in next step, if you're going to multiply by 3R1 plus adding R3, and second, if you need here is pivot 0, you need pivot 0, you will multiply by minus 5R1 plus adding R3. So factor will be involved like this way, 1 minus 2, here will be 0 0 0, right? So here is 0, positive, that is basically will be, you will see minus 3 term. If you're going to multiply by this term and add in this term, here will be, you can see that 4, negative 4, if you have some value 0, so positive into positive, that will be 5, and add this in this term, here will be, you can say that 3. So if you're going to multiply positive into negative into negative, that is positive, here will be 9, right? So you have some values like this way. So interchanging R2 by I3, so I'm going to remove and this side for my calculations terms. So I'm going to interchanging R2 by R3, you will receive the matrix like this way, negative of 2, here will be negative 0 0 0, right? So here will be going to change, so here is 0 3 9, here is 0, negative of 3 and negative of 4. If you're going to multiply by 1 by 3 term, so 1 by 3 term will be pivot 1, right? So second step we can say that 3 R1 2 plus adding R3. We reduce some step here, so here will be 1, negative of 1, negative of 2, 0, 0, 0, right? So here will be, that is 0, 1, that is will be equal to 3. When you're going to divide this 1 divided by 3, and 3 is equal to 3, you already know calculation. So if you're going to multiply by here is 3, that factor is 0. Here you're going to multiply by the term of negative, so we'll receive that is 4 into that is this 3 term, 3 into 3, that is 9, then you will term add, you will receive 5, right? So if you're going to multiply by 1 by 5, here it will be a pivot 1, so I can remove, here is 1 factor. So you will improve some sort of some system of equations. So here is a1, negative of a2 minus 2a3 is equal to 0. From second row, you will receive a2 plus 3a3 is equal to 0. And third row, you have noticed that a3 is equal to 0. If you're going to put this value of a3 in equation number 2, you will see the value of a2 is equal to 0. So a2, now we put these two values in equation this, we receive the value a1 is equal to 0 term. So if you notice that here is a1 equal to 0, a2 equal to 0, a3 equal to 0, right? So for example, I'm going to remove this side. So if for example I choose all these values and put on this side of an expression, if you notice that here will be 0 term. For example, I'm going to show my marker, right marker is 0, here is 0, here is 0. You notice that 0 term multiply left hand side of an expression is equal to right hand side of an expression. And second thing that we can also say that a1 is equal to a2 is equal to a3 is equal to 0. That is trivial solution. And trivial solution also known as 0 to n tuples type of solutions. Right. So it satisfies the equation. So the given vectors generates R3. So the given set S is basis for R3, right? So this set is basically produce the R3 space if satisfy the condition. So it means that it generates the space type, generate vector R3. So it will be a becomes of a R3 space. And second, you can also say that A1, A2, A3 value is 0. Satisfy left hand side is equal to right hand side of an expression. It is a linearly independent vector set. If linearly independent vector set, it means that it generates the space of R3. So this is the basic way you can check any sort of vectors, how any vectors can generate a space, R3 space. How you can check that with the set of vectors is the basis of any space or not, right? So this is the basic criteria you can find out the basis of any space from any space of the vectors, right? Here I'm going to stop my lectures. You have any sort of question, you may give me a comment. I will discuss in next video. So see you shortly till next video. Bye bye.